Okay, so in this video I'll talk about introduction to chatbots. Now chatbots are very common. Almost every web portal wants a chatbot. So whether it is banking sector or or any website, right? Any e-commerce website or any travel booking website, all of them want chatbots on their websites. Okay, so let's talk about chatbots. At least a few perspectives about what can you think when somebody says a chatbot. Okay, so. Chatbots are also useful for automated support request handling, right, across lots of call center scenarios. So when chatbot comes to mind, people think of things like this: what can I help you with? So it's basically like a helper, assistant in some senses, specifically catering to questions related to a particular product or an enterprise and so on. Okay. A whole bunch of deep NLP goes into these chatbots, and typically, the area is actually called as dialogue modeling in that senses, and you want to model these conversations, right? So essentially, it's basically like saying there is a human which is interacting with an agent, right? And these interactions are not just typical question answering. It's basically a multi-turn interaction. So, you say something as a human, the agent replies back something, and then you say something building up on the context of what you have said earlier. Okay, so therefore it involves much more than just doing pairwise question answering. It also involves maintaining context or retaining context from previous part of the conversation, so as to make meaningful conversations and more consistent conversation as a whole. Right. So building chatbots involves a whole bunch of NLP. Although many chatbots which are publicly available as of now are typical rule-based systems. So oftentimes people build chatbots by just by just hand coding a few rules, and oftentimes the chatbots work nicely in restricted domains, in specific domains. Like for example, if you want to just book a cab. A chatbot for cab booking can be actually nicely automated using simple rule-based mechanisms, right? Or if you want to just do typical banking scenarios, very restricted ones, then many of these things can be sort of automated using rule-based scenarios. But otherwise, if you have to build more generic chatbots, NLP is required, natural language processing, and a lot of deep learning on top of basic traditional NLP. Okay. Now, chatbots basically involve two kinds of models. Either they are retrieval-based chatbots or generative models. Okay, so retrieval-based models, which are easier to learn, comparatively easier to learn, use a repository of predefined responses and some kind of heuristic to pick an appropriate response based on the input and context. Okay. So the idea is, you can think of it, for example, let's say for a particular product, you have like lots of FAQ pages, okay? So, or other FAQ page, and the FAQ page has lots of question answer pairs, okay? Now, when a user comes in and basically asks a particular question, what you want to do is to really match the question to the bunch of questions that you have in the question answer pair database, right? Find the most similar question and provide the answer as a response to the question the user asked, okay? So the heuristic could be as simple as, the model that you built could be as simple as a rule-based expression match, or it can be as complex as an ensemble of machine learning, deep learning classifiers. Okay. These systems don't generate any new text. They just pick a response from a fixed question answer pair database. So therefore, the chances of giving out things which don't make sense is rather low. So therefore, they are sort of easier to create. Okay. However, retrieval-based models, of course, assume that you have a data set of question answer pairs or a data set of predefined responses somewhere, a repository of predefined responses. Okay. On the other hand, there are these generative models which are more harder to build. Okay. They don't rely on any predefined responses. They generate new responses from scratch. Okay. So generative models are typically based on machine translation techniques, but instead of translating from one language to another, which is what machine translation is, we translate from an input to an output. Okay. For example, if you have an incoming email saying, "Are you free tomorrow?" Well, you usually reply, "Yes, what's up?" Okay. So using a whole bunch of such incoming email and reply pairs, you can actually learn models like this one, a sequence to sequence learning model. Okay, for example, using typical LSTMs or more recently popular transformer networks and so on. Okay, so it could be a fun exercise to actually build a Twitter bot where you can actually download a whole bunch of tweets and their replies by other Twitter users, and therefore learn a sequence learning model, which basically takes input as, let's say, hello, how are you, and the response is I'm good, how are you, right? Something of that sort. Okay, so those are generative models, and because they're generating word by word a response by learning it over a large data set, okay, by learning a real deep learning machine learning model. Okay, so in general, generative models are difficult to build. Retrieval models are rather easier to build. But both of those approaches have their pros and cons. Okay, due to repository of handcrafted responses, retrieval models generally don't make grammatical mistakes. They are pretty nice because they are going to give out responses which were written in by humans. Okay. However, they may be unable to handle unseen cases, okay, for which no appropriate predefined response exists. For example, let's say you are building a Xbox chatbot, or such that if some customer comes to this chatbot, they basically say, hey, I have this particular error code on my Xbox. Now, let's say that this error code is a new one and there is no documentation which exists around it. Now, it's therefore difficult for the bot to basically give any response related to that error code. Okay. So that's that. For the same reason, these models can't refer back to the contextual entity information like names mentioned earlier in the conversation. So, the context is more or less lost in retrieval models because retrieval-based models just try to get a response without using any context in the past. Okay, so that's the context in terms of the current conversation. Right? So that's a problem with retrieval-based models. On the other hand, generative models are smarter. They can actually refer back to entities in the input and give the impression that you're talking to a human. So they can be, at least in theory, in principle, they are pretty smart. Okay? They can actually be very much context sensitive. Okay? However, these models are hard to train. Okay? They require large amounts of data to train useful models. They're quite likely to make grammatical mistakes because the response is actually generated word by word. Therefore, quite likely that they make grammatical mistakes, especially on longer sentences, and typically require large amounts of training data, right? Which also means large amounts of training time and so on. Okay. So deep learning techniques can be used for both retrieval as well as generative models, but research seems to be moving more towards generative models. All the current production systems are more or less retrieval based as of now. Okay. So that's basically about chatbots from a retrieval versus generative perspective. Now, about conversations, there could be long conversations or short ones. Long conversations are more difficult to automate, while short ones, the goal is to create a single response to a single input, and therefore it's easy to manage in that senses. Okay. Usually, short conversations are single turn. So, for example, if it's about taxi booking chatbot, typically the agent could ask, hey, where do you want the taxi from? And the guy would say a particular place. Where do you want to go? Particular place, and so on. So pretty context insensitive in that senses, and also pretty short replies and questions. So those kinds of things are usually easy to build versus longer conversations, which are more harder to build. So then there are long conversations where you go through multiple turns and need to keep track of what has been said. So more convoluted conversations, so to say. So customer support conversations are typically long conversation threads with multiple questions. So if my washing machine is not working and I call up this customer care, or rather calling up, I use a chatbot, then I would not stop by just saying one thing. I would generally be asking multiple perspectives, giving multiple forms of context and so on, leading to longer conversations which are difficult for automated systems to keep going, right? So in general, we could look at the chatbots from these perspectives: open domain chatbots versus closed domain chatbots, okay? And retrieval based responses or generative based responses, okay? So in general, open domain chatbots basically meaning very general chatbots. You could ask anything and everything, right? While closed domain chatbot meaning a chatbot which is meant for a particular domain only, like banking or healthcare and so on. Okay. So now in general, the easiest ones to build are closed domain ones, and which are retrieval based. Okay. So if this is a eye hospital, then it has a lots of FAQ pages anyway. you can very easily build a very health focused or eye care focused retrieval based chatbot on top of it, right? They're the easiest to build and therefore the most common ones as well. But there are other chatbots like generative based and a closed domain chatbot, still possible but requires lots of labeled data to train. Okay, smart machine, deep learning based machine, hard to build. Okay, generative chatbots for open domain are the hardest to build, because hey, you can then ask this guy anything and everything under the sun, and the chatbot is supposed to be answering that. Okay. Retrieval-based chatbots on open domain are sort of impossible to build, more or less because you do not have an exhaustive set of question-answer pairs. So, of course, some kind of this thing is basically what Quora does. But it's sort of impossible to build a completely open domain chatbot which can basically just work on retrieval basis and therefore give you results. Okay. So, more about open domain versus closed domain chatbots. In open domain chatbot, in open domain setting, the user can take conversation anywhere really, because it's not specific to a particular enterprise or particular domain. There isn't necessarily a well-defined goal or an intention that even the user has in mind. Okay. Conversations on social media sites like Twitter or Reddit are really like that. So they're typically open domain. They can go in all kinds of directions. Okay. The infinite number of topics and the fact that a certain amount of world knowledge is also involved to create reasonable responses makes this a much more harder problem. Okay. So when we basically do conversations, of course, it's not just about the particular domain that we, it's not just about the particular question that we are answering, but we have a lot of world knowledge that we basically use to generate or to come up with the answer. Now, which is very difficult to sort of encode in an open domain chatbot. Closed domain chatbots is a easier setting, and the space of all possible inputs and outputs somewhat restricted, right? And when people interact with closed domain chatbots, they have a very specific goal in mind, and therefore they are sort of easier to build. Technical customer support or shopping assistants are sort of examples of closed domain chatbots. So if you are basically on some travel website, now, since you've entered a query, the chatbot already has the context as to where do you want to go and so on. Or you can actually start conversing with the chatbot also. Source, destination, the overall expenditure, things of that kind are the things that sort of matter in a closed domain thing. Okay. So therefore, they are easier to build. These systems don't need to be able to talk about politics or general other world knowledge. They need world knowledge, but a very limited set of world knowledge. Right? They just need to fulfill their specific task as efficiently as possible. So in fact, in open domain, even maintaining a reasonable conversation is a big deal. But in closed domain, when you're building a chatbot, it's not just about maintaining the conversation, but finishing off the conversation with a customer success in small amount of time is a good metric to measure how good your chatbot is. Okay, so when building chatbots, there are these four main kinds of challenges that one faces. Okay. How to incorporate context. Okay. So every chatbot really should do a conversation with a context. How to incorporate context. Coherent personality, right? So when you talk to a human, to an age, to a person, right? They maintain a particular kind of personality. How do you make sure that the chatbot actually has that personality? Evaluation of models. How do you evaluate your chatbot? How good a chatbot is? Okay. And lastly, intention and diversity. So, we'll talk about each of these challenges one by one. Okay. Let's start with the first one. So, how do you incorporate context in general? Right. So, the idea is conversation is not just a sequence of question-answer pairs. It's basically a coherent sequence. So, there is a relationship between the second question-answer pair to the previous one and so on. Okay. So to produce sensible responses, you need to incorporate both the linguistic context and the physical context, right? It has to make sense as far as the English language, the grammar goes, and also semantically. Okay. So look at this conversation, a funny one. So can you tell me why truth is not lie? You perceive truth to be not lie, but is that true? Okay. They're very different. So good to know. I'll store that info in my database. Don't you think so? I kind of do, but in other aspects, I don't. It depends on the right context. So, the idea is that context information is very important when doing meaningful conversations. So in long dialogues specifically, people keep track of what has been said and what information has been exchanged. That's an example of linguistic context. One may also need to incorporate other kinds of contextual data. For example, date, time, location, information about the user, and so on. So the longer the conversations and the more important the context, the more difficult the problem actually becomes. So and here the context really means the conversation context plus the physical context in terms of date, location, time of day, and so on, right? So how do you incorporate context is a difficult problem. The second one is coherent personality. So the idea is that if we do not incorporate context, in general, maintaining coherent personality is difficult. For example, look at this conversation. Where do you live now? I live in Los Angeles. In which city do you live now? I live in Madrid. Now, that just doesn't make any sense. So, if you're doing a conversation, if you are living in one city, Los Angeles, you can't be living in Madrid, which is in Spain, right? And which country do you live now? Completely inconsistent. Well, England, right? So when generating responses, ideally the agent should produce consistent answers to semantically identical inputs. All of these three questions, more or less mean the same thing, right? Or they are semantically very relevant, very similar, right? But the answers can be different because of this probabilistic nature of the replies that the chatbots generate. Okay, so but there must be some grounding to a fact base or a knowledge base, which sort of defines the personality of the chatbot. How to incorporate that in a typical chat system is not easy. Okay. Now, how do you evaluate these chatbot models, right? So the best measurement process is to measure whether or not the user task is satisfied after interacting with the chatbot. Okay. But it's of course very difficult to measure because then the measure becomes a very, very task-specific measure. Okay. So for example, does it solve a customer support problem or not? Or many of these automated chatbot companies, they basically have a chatbot where the customer can interact with to find a solution to their problem. But if not, then they redirect to an actual human agent, right? So how many times that redirection was required and how many times it was the automated bot that could just answer the question, okay? But such labels, are expensive to obtain. So figuring out the labels corresponding to whether the customer was satisfied or not, they're expensive to obtain. They're not easy to obtain because they require human judgment and evaluation. Whether the customer was happy or not, or did they just hang up the chatbot because they couldn't find an answer and they were too frustrated, you never know, right? So sometimes there's no well-defined goal, as is the case with open domain models. Now, you never know, because success is very subjective in terms of open domain conversations. Common metrics which are commonly used, such as the blue score that are used for other NLP tasks like machine translation, are based on text matching, aren't really well suited for this chatbot evaluation, because sensible responses can contain completely different sets of words or sentences. So you could basically say that given this question, if the answer is one of these, then it is correct. But hey, well, the answer could really mean the same thing, but could be expressed in completely different words or phrases. And therefore, even these kinds of scores don't make much sense when evaluating chatbots. Okay. The last problem that you encounter when you're building chatbots is this intention and diversity. Okay. So the problem with the generative systems is that they generate a whole bunch of junk responses, okay, or generic responses. For example, that's great, or I don't know, that work for a lot of input cases. Lots of things. You basically the customer basically comes and says, "Hey, my washing machine is not working, and it is blah 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 is the problem. What can I do? I don't know." Can be a generic response, right? But that's not a great response. You need to have diversity beyond such trivial generic responses. So generative systems aren't trained to have specific intentions. They lack this, right? They lack this kind of diversity, okay, which humans have. So humans typically produce responses that are specific to the input and they carry an intention, right? Because generative systems, and particularly the open domain generative systems aren't really trained to have specific intentions, they lack this kind of diversity, which is again a challenge when you build such chatbots. Okay. So lastly, let's talk about the current status of chatbots. So many companies sort of start off by outsourcing their conversations to human workers and sort of promise that they can automate it once they have collected enough data. So for example, let's take a story of Xbox, right? Or for that matter, any other service or product, right? So most of the companies sort of start by saying, hey, we'll build human call centers where human agents are going to respond to such things, to such customer care calls, right? But call centers have a problem. So the first problem is you need to sort of hire people. And these jobs are repetitive in nature. People find them boring many times, but on the other hand, there's also money involved. You need to pay people per call. Right? Now, if you can automate that, you can of course save a lot of money. Right? On the other hand, you could also outsource these kinds of things to crowdsourced platforms, which can also allow you to scale depending on customer care requests and customer care calls and so on. Right? However, they all suffer from various kinds of things. For example, on crowdsourcing platforms, you can never guarantee the quality of the answer that these crowdsourced workers provide for customer care queries. Okay. Now, more recently what people are trying to do is to now therefore look at automated chatbots as a solution. Automated chatbots are likely to happen only if they're operating in a pretty narrow domain. For example, a chat interface to call an Uber, for example. Now, that's a very narrow domain, and their automated chatbots make a lot of sense. Okay. So anything that is a little more open domain, like sales emails or stuff of that kind, is really beyond what is possible with a reasonable accuracy as of now. Okay. So however, we can also use these systems to assist human workers. So while automated chatbots are impossible when you talk about open domain, but these chatbots can actually assist human workers by proposing and correcting responses, right? That's much more feasible. So, they can actually create some responses which some humans can actually just change a little and then push them out as the actual response to the user. Okay. Grammatical mistakes in production systems are very costly and may drive away users. They may think, hey, well, this chatbot doesn't even know English grammar. How can he or she or rather, it can sort of solve my problem? So that's why most systems are probably best off using retrieval-based mechanisms rather than generative mechanisms. Okay. So retrieval-based, as we we already mentioned, they are based on already existing responses, and therefore they are less prone to grammatical errors. Okay. So if companies can somehow get their hands on huge amounts of data, then generative models become feasible. But again, because of the grammatical errors, such systems are generally not preferred as the final system. They can only be assistive in nature, right? But they must be assisted, right, by other techniques as well to prevent them from going off the rails, like Microsoft's Tay. Okay. So if you don't know about this Tay project, which Microsoft launched at some point, just search for Tay. Right. Tay was a Twitter bot that Microsoft had designed at some point, which would sort of respond to general questions, open domain questions on Twitter. Very quickly, Tay got into the hands of bad guys. So in the sense, bad guys started talking stuff to Tay, it got trained on not so nice comments, and it also started putting out garbage, right? So and then Microsoft had to decide to shut down the bot within a few days, within a few hours of making it publicly online, right? Of it becoming popular. Okay. So therefore, chatbots, general open domain chatbots are good, or generative chatbots are great as research pieces, but making them capable of being real commercially viable, will require lots of research work. What is more common now are closed domain retrieval based chatbots. Okay, so that was a basic intro to chatbots. Of course, there is much more to how to design chatbots. There are various platforms to create nice chatbots like Dialogflow or Rasa.ai and so on. If you have more comments about chatbots, or if you have worked with these platforms to build chatbots, more perspectives about chatbots, do put them in the comments below.